y'all, and welcome to another high-powered episode of the High Voltage Live Show. I'm your host, Willie Snyder, coming to you live from the snowy Mile High City in Denver, Colorado. I'm joined by my awesome partner in crime, Mr. King James Stallcup, over there in Big Sky Country, Texas, old Longhorn Country. Give him an old hook 'em horns over there from the Mile High City. Awesome to have you, and I want to wish everyone a happy Pi Day, old 3.14 day. So, pretty awesome to be hitting a little bit of a holiday here, and looks like we already got old Daniel J jumping in the house. He's like the freaking piranha, just waiting, man. He's just like that shark. You just see that fin coming out of the water, and he's ready to get you on the quiz tonight. So really awesome that James picked the topic this week. So we'll see how he can do picking his own topic. But I really appreciate it. And I agree with you, James. I think that was an interesting topic. So it'll be a lot of fun to do this week. So hopefully I pick some good ones that he can guess on. So we know he'll be 100% on his second answers at least. So get the consolation prize there, Daniel. We'll give you your second answer.
That sounds like fun.
Oh yeah, they closed our job site too, Daniel. I don't know where you're working at, but when we're up there in Boulder, and it was pretty bad. Got quite a bit up there, so I think they got like 15 inches or something. But roads really weren't too bad, but they called it. The foreman was trying to make it in, and he couldn't. So
yeah.
He's coming from the south. I didn't even get nothing here. I'm a little bit east of Denver, and it was just everything west of I-25 got hit. So
okay, before we were come on, we got a huge storm that come through. It was loud around here. Bam, 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 and then the internet went off, and I called you right away. I said, "Hey, I don't know when I'm gonna be on." And was it 5 minutes before it came on before the show? I was like, damn, boy, I haven't gotten that close. So,
yeah, I was sitting there practicing how to do the intro and how to do it all so I could do it right. I don't think I even screwed it up the one time I did it, but I did a couple times, I think, I started it. But it's always awesome to have so much participation. Like, dude, I hit 100,000 again. So I just have like so many people that's jumping in, participating with our myths, and this week was kind of a little bit of a situation I kind of went over with you. So we'll try to see if you're able to capture that as far as, kind of what the AHJ is going to interpret that and how he's going to rule on that. And we'll just kind of go from there. But the meme this week was a fresh stolen one from the Wall of Shame group. And, dude, I couldn't believe electrical code discussion for awesome electricians. We're at like 18.8 thousand already. Like, we're almost at 19,000, so it's just crazy how fast these groups grow when you start bringing all this content and start building them up and stuff. So,
oh yeah, electrical codes and standard discussions already over 1.2, and we were when we had 400 since last week. God dang, I hate that, because next thing I know, I'm going through deleting a whole bunch of freaking emails, just Facebook.
Oh yeah,
God dang. And but we hit that, and I also checked right when we came on. I was checking to see we're on Rumble. It's working.
Nice.
So I got that.
Welcome, people from the Rumble side. So that's pretty awesome.
Finally figured that sucker out.
Yeah, and it's really cool because I got a bunch of my buddies that are trying to get on Rumble. So I'll probably see you guys next week because they probably don't know that it's on this week, but. Pretty awesome. We'll be checking to make sure, because that could be. I didn't see the error message come on this time, so I'm pretty sure you did it right.
Oh, it's right, because I've already gone over and looked, and it's up and running. I can tell you 100% it's running. So.
All right, but anyway, the meme this week was a freshly stolen one, and it was stolen from the Wall of Shame, and whoever made this meme got me laughing, and I decided to run it.
All right, let's run it.
So the reason I find that one so funny is one of the, I'm not going to mention names of the utility providers, But there was one of the utility providers, and they were kind of known for like the broadband kind of dial-up service. And then there's another one of the utility providers that's more known for like the digital cable. And so we're sitting out there, we're talking, I'm having a meeting with them all to see like what they require. And the one guys with the cable, they're just like, oh no, I don't need anything, I don't need anything out to the street. Well, the other guys, they're like, well, we need 2 4-inch. And I'm like, what? And I mean, I have 4 buildings. So they're sitting there telling me they need 8 4-inch coming to this place, And I was all, what? What do you need so much for? And they said, oh, well, 1 4-inch is for what we need, and the other 4-inch is for future. And I was like, you guys are calling yourself the future? Oh, it was so funny. Like everyone started busting up laughing. But it's a lot of fun to do these shows and joke around from like a real life standpoint where we can joke around stuff, little stories from the job site. So feel free to jump in and tell us any of your questions or anything you have from the job sites. We'll try to answer them best we can.
Sure thing. All right, let's roll the myth. What do you got this week?
Story from the job site this week. So let's roll it.
All right.
It's time for Myth of the Week.
All right, so a newly formed myth number 102. And if you guys don't want to watch our video or anything, you can check me out on Spotify under Nat King Code. And I have an audio version of this same Myth of the Week podcast. So this myth number 102, and James always forgets to change the pictures, but this one is basically our pull boxes, not required to be accessible when only used as a pull point. So I did have a picture of like a floor box. So kind of my angle on this is like, let's just say you're gonna put furniture over top of this floor box. How permanent is that furniture part of the building? Like, are you technically removing a piece of the building to access that, or are you just moving a little piece of furniture? So and this actually, we ran into this where they were trying to require us to feed some furniture through these floor boxes, and they're planning on technically building this furniture over top of these floor boxes. Now you can access them, you can pull one of the panels off and get to them and access them and stuff. So in my opinion, I think it's fine, but there could be, I would say, some inspectors that would say that they're not accessible enough without having to basically take apart pieces of the building. So this one, it was kind of a little bit of a gray area, and I kind of threw it out there to kind of get Stallcup's take on it, to kind of see what his answer is on it. And like, to me, what my opinion is if we're gonna do any kind of work on that furniture, we're gonna have to move it and access it and all that kind of stuff. So I don't really see too much of a real world issue with it, but it's gonna be tricky. It's not easily accessible. So I don't know if easily accessible is really defined. So I'll let you take it from here, James.
Well, I just sort of looked at it from the standpoint in 314.29, because what it says is boxes, conduit bodies, and handheld enclosures shall be installed so that the wiring contained in them can be rendered accessible. So you got to have, it's got to be accessible so you can get to the wiring. Basically, that's the main part. And then when you look at A, it says boxes and conduit bodies shall be installed so that contained wiring can be accessed without removing any part of the building or structure. So I sort of look at it, say I've got a desk here, like where I'm at right now. I've got a floor plug, and if I need to get access to that wiring, I'm going to move the desk. All right. So that is what you got to look at. It doesn't say readily accessible.
True.
That's the key. It has to be accessible, and it says without removing any part of the building or structure, which I'm not doing. So if that is the case, and I've got a floor plug down there, a box on the floor, and I can reach down there and I can unscrew it and have access to the wire, I'd consider it okay. It's no different than take like I could say above a suspended ceiling where I got a box, or maybe I have a raised floor for like we used to set up with a big computer systems in there and everything, and they'd ventilate that, and you would have the suction cup. That was accessible. You could get down to it. And that's accessibility to me. You might have to move something to get there, but it's still accessible. So
and I agree with that too. And the kind of my point on this one is with these floor boxes, there would really be no reason that you would need to remove the cover to get access to the wiring. The wiring can be accessed with the cover installed. So that's kind of where it was kind of one of those things, like, do you have to take that cover off? Because, you know, the whole thing is that the cover can remain in place and I could pull the wire through there, you know? So it's just kind of, that's where I kind of saw it as a gray area, because there could be some screws on this box that you might not be able to get to easily. And to me, you just move the furniture a little bit, you know? So I don't see that. That's the
way I look at it. And I think that I think it's perfectly fine in my opinion. Now, you might get an inspector, may look at it, and you know, you could have a module unit in, and this I might agree with them on. But say I have a module unit that comes in, and all the desks above it are hooked into that module unit, and it's running down there, and you've got 8, 10, 12, whatever there, you're not going to move that. So if you got something where the wall is over there, I'd consider that to be a problem at that point. But if you just got a desk there or something and you can move it out and get access, I don't see a problem with it. So that's how I think the inspector would view that. That's just my opinion on it. So
right on. Well, I appreciate your takes there, and like I say, I agree with you. I don't think it's a real big world issue or anything. I just kind of wanted to run it as the myth, and there was a lot of people that were that followed NEC code that enjoyed that one, because they're like, hey, wait a minute, you know, that's a good point, you know. I mean, it's not like I'm pouring a concrete wall over top of it, you know what I mean, or you know, anything that is immovable later, you know. I mean, even like I was telling you, even if you have 7, 10 desks on there, you could still move the one side and kind of tilt it, you know what I mean. It's not, because the box is at one end, and the one end is pretty light, you know. So one side of it's real easy to move. The other side, like, I could agree with you, if you had multiple floor boxes that were all covered up, then it's highly unlikely you're going to move that whole row over.
That's right. So that's what I'm saying. It depends on the installation and if it's easy to get to, you know. I mean, can I move it, you know, without damaging the modular unit and all that? Those are things that you would have to look at in that case, in my opinion.
10-4. Right on. Well, I appreciate it, and sounds like the apprentices are going to have to go grab their code books and get ready for the topic this week.
Let's get her going. All right.
I still owe you a new song. I'm working on it. So
been working on it for like 20 years now.
I know. It's all good. I just been real busy working OT.
Doesn't bother me. You know, we're always, you know, we'll change something here and there every now and then when we get to it. You know, I mean, I spent all night last. That's why I forgot that dang picture. I was trying to figure out how to get the damn rumble on. And I was reading all this documentation. I didn't go to bed till 4 o'clock in the morning. And then I turned around, got up at 9, and then had to run some errands stuff. I was like, man, I'm still tired. You can probably tell my eyes are a little baggy today because I'm sleeping.
Yeah, so just keep in mind the myth next week will have the picture from this week, so
yeah,
it'll be all good. But no, I appreciate you, sir.
All right. Now, where we finished up last week was doing motors. So we're going to go through and do the exercise problems for motors, but we're getting close to getting through. Probably if we don't get to it tonight, next week we'll definitely get through all the overcurrent protection devices, and then we get into residential and commercial. So we're moving along pretty good. I mean, we're getting quite a bit done. So, all right, let's get started. Where were we at when we started this? All right. Now, the first one, now everybody remember this. I'm going to sort of go over this a little bit just to refresh everybody. But I said, anytime you're taking and you're sizing your overcurrent protection devices are conductors, you want to use the amperage values that are in the tables in 430.247 through 250. And we get that permission over in 430.6A1. All right. Now, when I'm doing the overload protection, I'm going to look at 430.6A2, and it's going to tell me to use the nameplate. All right. So I just want to make sure everybody sort of remembers that. And one thing I've started with, like I've done every one of these, is I always reemphasize the rule of thumb one more time. If you're sizing your overcurrent protection device at 125% or less, go up to the next standard size. Once you get over that 125% percentage, then what we're going to do is we're going to drop down to the next standard size. The only places you're not going to have that is where I have to protect the conductor, which is sized at 250% for phase converters, and then also transformers. But we went over that last week and the week before, and I was talking about that, and I said, now when you're doing those transformers, when you're looking at table 450.3A and B, if you don't have that superscript 1 there that drops you down to the notes that allows you to go up to the next standard size. Okay, if it didn't have that superscript 1, we dropped down when we got to the percentages above 125%. Okay, so just to get that started. Now, when you look at this illustration, basically we just need to know a couple of values here. All right, we know it's a 50 horsepower motor, it's 3-phase 460 volt design B, and we're going to size a non-time delayed fuse. So when I go to look in step 1 and I'm going to get the amperage, since this is 3-phase, we're going to look at table 430.250, which was permitted once again for 430.6A1, and you go pick up the 460 volt and you come down, line it up with a 50 horsepower, and it's going to tell you it's good for 65 amps. All right. Now, the next thing that you're going to get into, and I said make sure you do this in the last week. I said right there at table 430.248 and 250, write down sizing OCPD, and then put 430.52C1, and then table 430.52C1. Okay, that's where we want to go, because what it's going to tell you in 430.52C1, the heading's going to say in accordance with table 430.52C1, and it says a protected device that has a rating or setting, listen one more time, not exceeding the value calculated. So that means I can't exceed it, so I have to do what? Drop down to the next standard size. Okay? So when I go over to my table and I come down and I pick up my non-time delay fuse for full take motor, it's going to tell you to take it at 300%. All right? So I'm going to take the 65 amps at 300%. That's going to give me 195 amps. And then if I look at step 4, and I actually go over and I look at 430.52C1 A and B, it's going to tell you and I'm automatically permitted. I can go up to the next standard size if it didn't start the inrush current, which would be a 200 amp. But if it'll start based on not exceeding the calculated value, I can drop down to the next standard size, which is 175 amp. So we got a minimum size at 175 and a next size at 200. Now, you've probably seen some of these arguments on the groups and stuff, and they say, they try to tell you there's no such thing as a minimum. What the minimum is a starting point. Okay. And if you go over, and I give a good example of this, if you go over in the 2023 and you look at 440.22a, what they did, they added text in there, and it looks just like motors. And what I always tell everybody is, when you go look at a nameplate, how many times have you looked on there and you have a hacker breaker rating for that AC unit, and it has a minimum and a maximum? That is a terminology that has been used, and we've been doing this forever this way. I mean, even when NFPA published our books, the table still stated the same in 430.52, and it says maximum, but that's the maximum percentage for that table. And and you got people like Jeremy and Ted and all of them, they come in, that ain't right, there's no maximum, there's no minimum. And I'm like, I don't know what y'all arguing about. You going to tell me that the staff at NFPA is all incorrect too? Because they added it. We had 3 editors at NFPA looking at the technical validity of what we published, and it's been that way for, we've had in the books that way 30 years. I mean, now all of a sudden it's wrong because they say so. I mean,
yeah. And when have you ever heard about having 2 maximums?
That's true. And that's another thing I brought up to them. I said, well, if I go down and pick up in the 2023 code, and I pick up 430.52 C1, and I go down right below that, and you pick up B, I said, what is B deal with? I said, that's maximum. I said, so you're going to tell, I said, are you telling me I have 2 maximums? And they said, there you go. You're just twisting the code to meet your lies. And I'm like, no, I'm trying to tell you that's what it says. But anyway, besides that, and then we'll do the next one, and it's the exact same thing. We're using the same motor thing. The only difference here is I'm doing a time delay fuse. Okay. And if you go look at the table and you pick up your time delay fuse squirrel cage, it's going to tell you take it at 175%. So you just take 65 amps and 175%. That gives you 113.75. The next size below that's 110, and I'm automatically permitted to go up to the next size if I want to. So I could have 110 starting point, or I could go up to the next size due to inrush current because 110 amp didn't hold it, and go to a 125 amp. Okay. Right. Now, when I come over here and I look at an instantaneous trip circuit breaker, well, you're going to look over, and if you look at the table, it's going to tell you this, and we have a design B energy efficient motor here. It's going to tell you take it at 1100%. Okay. Now, you take the 65 amps at 1100%, that's 715 amps. That's your minimum setting to start with. Right. Then if you go over and you pick up C3 is going to allow you to go up to 1700%, and you'll pick up C3 2B. Okay. And when you pick that up down there, it talks about your design B energy efficient motors, and it tells you, and shall in no case exceed 1700%. Okay.
Oh, welcome in. Thanks for joining us tonight.
Hey, thanks, brother. So take 65 amps at 1700%. That's going to give you a maximum setting of 1,105 amps. Now, the point behind this is we're using the same type horsepower rated motor and all that. But what we're trying to point out here is it just comes down. You're still following the same type step-by-step method. You just have to find the percentage that's going to apply. So when I look at this next, and it's an inverse time circuit breaker, and if I look at the table for my 50 horsepower, 460 volt three-phase design B, it's going to tell you take it at 250%. So if you notice, based on the table, for non-time delay, we took it at 300%, time delay 175. Then when I got up to my instantaneous, I took it at 1100%. Then I had to look at C3, allowed me to go to 1700%. And then you look here at the table for my inverse time, it tells you take it at 250. So I take 65 amps at 250%. That gives me 162.5 amps. The next size below that's a 150. And then if it won't start due to inrush current, I can just go up to the next standard size and put a 175 amp overcurrent device there. Okay?
Yeah.
Now, when you look at that, that's not hard. And a lot of people have a lot of problems following how to do these motor calculations, transformers and stuff. If you just follow this step-by-step procedure and learn where to get the percentages, you're not going to have a problem putting this together.
And I'm going to put this thumb roll up for everybody. This is one of James's thumb rolls that he does. And I say generally just because there's a couple instances where it doesn't apply with phase converters.
Well, we're going to do that tonight, the phase converter. We've already done the transformer and showed that, and we showed the notes in there for that. Okay.
Okay.
Now, this one, this is your maximum size. Okay. Now, all I'm going to be doing is looking right at 43052C1 and come down, depending on what cycle you're in. You'd be exception 1 and exception 2, or if you're in 2023, it'd be C1A and B. Okay. So it's same calculation, same percentages. They just changed instead of exception, it's full code text now. But look at this. I've got the same motor here. Okay. Now I'm going to look at the maximum. And if I drop down to exception 2, or I'll look at C1B, depending on which one y'all are looking at, you come down, you pick it up. It's going to tell you that if I have non-time delay fuses, I can increase those. And it says, shall be permitted to be increased. And listen to what it says, but shall in no case exceed 400%. So it says I can't exceed. That means I got to do what? Drop down. And that's another percentage that's above the 125%. So if I take the 65 amps at 400%, that's going to give me 250 amps. And you'll need a 250 amp overcurrent protection device. Okay. Now, if I come over here and I look at my time delay fuses, and you come down and you pick up your time delay fuses, it tells you it's permitted to be increased, but in no case shall it exceed 225%. So I take 65 amps at 225%, it's 146.25 amps. The next size below that per table 246A, where your standard overcurrent device ratings are, that'll be 125 amp overcurrent device. And then when I get to my inverse time circuit breakers, exactly the same thing. Just like I had for that. Now, the only thing you have to look at here, the 400% is where the full load currents are 100 amps or less. If that horsepower motor was greater than 100 amps, you'd take it at 300%. Okay.
Right.
But this one, it's less than 100. So you just take the 65 amps times 400%, it's 260 amps. The next size below that is what? A 250 amp. Yeah. Now, that's not hard to follow. Now, the next one I'm going to get into is going to be where I have multiple motors. When you get into the multiple motors, like we talked about, we used to actually have this in our publication a little bit different. We used to take and do the calculation and drop down to the next standard size, add them up, and then go up to the next standard size. Well, the code making panel come in and they said, no, we want to do it this way. We want to take and calculate it, go up to the next standard size, add them up, and then drop down. Okay. So we changed this up from what they did, and that's probably like 3 cycles ago. I think they did this. Okay. But in this case, we got 4 motors. They're all three-phase 460-volt design B. I've got a 15, 20, 25, and 40 horsepower motor. You go over to table 430.250. You pick up your 460-volt, come down, pick up your 15 horsepower. Tells you it's good for 21 amps. The 20 horsepower is good for 27. Your 25 horsepower is good for 34 amps. And your 40 horsepower is good for 52 amps. Then you're going to go look at table 430.52C1. You'll pick up for an inverse time circuit breaker is what we're sizing here. And you come across, it'll tell you take it at 250%. And then you take that 250%, that gives you 130 amps, and go up to the next standard size, which is a 150 amp overcurrent device. Add the other three motors together, gives you 232 amps. Then you drop down, which would be a 225 amp overcurrent device. Okay?
Right.
So hopefully everybody that's been doing their homework got all these right. All right? And then when I get in and I start doing my overload protection, one of the things I told you is go look at 430.682, and it tells you when you're doing your overload protection to use the nameplate value. Now there's three items I need to look at here. I don't even really care what size motor is or what voltage it is. I want to know the nameplate, I want to know the temperature rise, and I want to know the service factor. That's it.
Right.
Now, we talked about this last week, and when you go over and you look at 430.28, it tells you, well, you have a motor with a service factor 1.5 or greater. So I got 1.15 or greater, and it says a temperature rise that's 40 degrees C or less. Okay? You'll take those at 125%. If you don't meet both of those, then you have to take it at 115%. Okay?
Okay.
So my nameplate value is 62. I met the temperature rise and service factor, take it at 125%, and that's going to tell me that my overload devices there will be rated at 77.5 amps. Now, if I need to go to a maximum size, then you're going to look over and you're going to pick up 430.32C, and when you go pick that up, you get the exact same language. The only difference is it tells you it's 140% if you meet both of them. If you don't meet both of them, then you got to take it at 130%. Well, in this case, we just kept it the same motor, so we know we met it. So you'll just take the 62 amps at 140%, and that'll give you 86.8 amps for the overload device. All right? So up to this point, that's pretty simple. Okay. Now, the next thing we're going to do to get you ready for next week in the homework, the first one we're going to do here is we're going to be looking at sizing the overcurrent protection device where I have a phase converter. So in this case, I've got a 20 horsepower, three-phase, 230 volt design B motor. Now, like I said, when you're sizing the overcurrent device, 430.6A1 will tell you to go look at the tables. In this case, since it's a three-phase, we're looking at table 430.250. And if I pick up my 230 volts and I come down, pick up 20 horsepower, it's going to tell you it's good for 54 amps. Now, what you're going to get into, you're going to go over and you're going to look at 455.7B because we're dealing with phase conversion here. And when you go pick up 455.7B, this is where we're going to be. Now, if I was doing a variable load, would be different. And then I've got one that I'm doing a fixed load. This is a fixed load here. Okay. And when you're sizing your overcurrent protection devices here, you have to look at this, and it's going to tell you to take that at 250%, and that'll give you 135 amps, but it's going to tell you you have to protect the conductor. So the next size overcurrent protection device above that for table 240.6A is 155 amp. Now, one of the things I like to do when I'm going through this kind of stuff like this is I like for everybody to go through and see just exactly what it says. Because when you look at 455.7B, it's going to tell you the overcurrent protection device determined for this section shall not exceed 125%. But if you look at that and it talks about above that, or the first sentence, it talks about the fixed loads and conductors are sized in accordance with 455.682. And then when you go up and look at that, that's when it tells you an ampacity not less than 250%. So some may miss that. You have to pay real close attention, because when you're doing a test, they ask you to size fixed load for a phase converter, and you go down and look at overcurrent protection. If it's got a section in there like this one does, you need to know you got to go back to 455.682, and that's where I picked up that 250%. Okay.
So I got a quick question for you on that step 3 where it says table 240.4G. Is that a table, or is that just?
Yeah.
Are you talking about the list of?
Yeah,
about the list of items.
Yeah, that's where you pick up specific conductor applications, and that's when I talked about you get into these different percentages that could be higher, and that's where it tells you. Yeah, I put that in there just so as a reminder. Where did I get the permission to get me over here to do that? And I started that in motors. Matter of fact, in motors, when I first started, I went through table 240.4G. And
a lot of people will get hung up like on an exam, because a lot of people don't read past 240.4D. So like you'll sit there and think, well, if I got to 240.4D, I can't even do any of this stuff. I don't even have permission to do any of this. But that's why you have to just read down and make sure you read down to 240.4G to make sure that whatever you're calculating is that specific conductor.
Correct. And that's why we go through these, and explain it step by step. And when you look at it, it's really not hard when you see the step procedures we put it in. Like this in here, this is simple. I just know what I'm looking at here. I know I've got to get the amperage, and I'm sizing an overcurrent device, so I know I have to use one of the tables. If I was doing overload, I know I need the nameplate. So I'll just get the amperage here. And based off what you just learned, we got a fixed load here. It's a specific load. So I'm going to put 250% on here. And you just sort of learn the sections. And that's why we go through this over and over and over. It's almost like repetition, but it's different items. But I'm really never changing anything. It's just what I need for this, what I need for this. And I'm still applying the same type of calculations. And I'll tell you one of the things that's very interesting about this. If you ever notice, pretty much everything I start off with is getting what? The amperage.
Yeah.
Even when I size my transformer, get the amperage. Once I get the amperage, then I'm looking for what? Percentage.
Yeah.
That's pretty much the way you do everything. Okay.
Right.
Now here's an AC unit. Okay. So I've got a compressor load of 21 amps and a condenser of 1.5. Same principles apply here. When I look at this, I'm going to look over at 440.228. Now, some of y'all that have your 2023, because we're doing this on 2020, but I do like to take and tie in the 2023 if there's a change that's made. And when you go over and look at 440.22A, they sort of did it like they had it in the last cycle. I expect this eventually to be 440.22A, A, and B, okay, and C. But right now they have them as exceptions like it used to be in 430.52C1. Now, when you look at this, when you pick up 440.22A, it tells you that you're going to be doing a protected device having a rating or setting. Now listen to what it says again. Not exceeding 175%. It says I can't exceed, so that means I'm going to do what? Drop down. Now, what they added in the 2023, they added an exception 1 here, and they said without doing any other type of calculation or anything, I'm automatically permitted to go up to the next standard size. And if it still won't start due to the interest current that motor, then you got an exception 2, and it tells me I can take it up to 225%. Well, that's interesting because this looks just like the motor portion now. But yet I used to come in and I'd look at a AC unit and I'd have a hacker breaker rating there that had a minimum and maximum setting. Well, where did they get that minimum maximum setting from? There had to be a percentage they had to go by. Well, they went by the code because it's designed that way. Okay. Sure. And that's one of the things. When UL is going out and they're listing and labeling equipment, they're going to look at the equipment and they're going to take the NEC into consideration. So if you have a UL listing and like say they have it for EVSE and they tell you don't put GFCI on it, guess what? The NEC was taken into consideration. And for somebody to come in and say, oh, no, you can't do that. You have to take and put GFCI on it. The code overrides it. No, it doesn't. It doesn't override the manufacturer's instructions because all that was taken into consideration when they gave the listing and labeling. So the same thing happens here. I've got a minimum and maximum size rating that was on that HVAC equipment. And what was that based on? It was based on the percentages in the code. All right. Now,
yeah, and this brings up an interesting point too. Like if you look at that, you have like, let's just say you have a 21 amp full load current, and you say, you know what, I'll use a number 12. You should be covered, and then you put it on a 40 amp breaker. It's code compliant from the minimum, but if worse comes to worse, you know that AC unit might give you permission to use like a number 10 with or number. I've even seen them do a number 12 to a 50 or a number 10 to a 50 or whatever. Mm-hmm. And if you drop to too low of an overcurrent device, then that overcurrent device get a nuisance trip.
That's right. Sure. Well, so then you need to go up. That's why they give you these different options. Right. Now, the other thing I'll say here is this is just like motors. When I do a motor, you take the largest motor at 125%. All other motors are added at what? 100% for sizing the conductors. The same thing applies here when I'm doing the overcurrent device. You take the largest at 175% for this case, for the AC unit, and then you add the condenser on at 1.5 amps. Okay? So I take 21 amps at 175% and add that 1.5 onto it. That gives me 38.25 amps. Now, I just read to you, it says it can't exceed the calculated value. So I look at table 240.6A, the next size below that is a 35 amp. Okay. Now I will tell you in the 2023 cycle, I've already added another step here. I've added step 3 that will pick up 440.22 A exception 1, and you'll be able to put a 40 amp there. Then I go down to the maximum size, which will be exception 2, that says I can take it at 225%, but I won't exceed the calculated value again. So I take the 21 amps at 225%, add that 1.5 amp condenser on there. That gives me 48.75 amps. The next size below that's 45 amps. So this calculation is actually changed in the 2023. I would have a 35, 40, and 45 amps set there. Okay?
Right.
Because you need to be aware of that.
One thing I want to mention too is when you're sizing on these AC units, all you have to cover is the minimum circuit ampacity. So if it says like a minimum circuit ampacity of 21 amps, you think, oh man, I can't put a number 12 on there. That's not true because the AC unit has 75 degrees C terminals. So all you have to do is go to that 75 degrees C column, and then you just go to that value, which number 12 is good on THHN for 25 amps, and then you can use a number 12 over 20 amps as long as you're in that 240.4G column with the AC unit.
Sure. And one other thing I want to point out is some will say, why didn't you go over and use the tables in 430.247 through 250? The reason is because this is an assembly. All right. So it's one unit, and therefore you're going to use the nameplate value that's on there. Okay. And this in here, you got a condenser of 19 amps and 1.5. You should automatically learn this. I'm going to go to 440.22A. I'm going to take it at 175 amps. If I need to do a maximum, it's 225%. Okay?
Right.
And then if they just say next size and they're doing the 2023 code, then you would do the minimum and just go up to the next size overcurrent device. Okay. Now, this is where we get into welders. All right. Now, you're going to go over and you're going to look at 630.11a. Now, when I get over here and I start looking at this particular chapter, there's 3 types that you're going to look at here. And you're going to have your resistant type welders, and then you're also going to have your non-motor generator welders and generator type welders. All right. Now, when you go over and you look at 630.11a, it's going to tie you in with table 630.11a, and that's where you're going to get your duty cycle multiplication factors for the arc welder. All right. So this, once again, and think about what I'm saying here, it's just like the AC unit. That is what? An assembly. It comes as one unit. So you're going to use the nameplate value here. Okay. So in this case, I've got a non-motor generator arc welder. It's 54 amps and it has an 80% duty cycle. Okay. So the first portion in step 1, get your amperage. That's what we always do. So we know it's 54 amps. Now I'm finding a percentage again. So I'm going to come over and I'm going to look for a non-motor generator type. I'm going to come down and I'm going to look at 89% come across. It's going to tell me that the duty cycle is 80%. So all I'm going to do is, I got a little mistake there. Oh no, that is my multiplier, 89. So I take that 80% duty cycle with a 0.89 multiplier, and it's going to tell you that it's good for 48.06 amps. Now I'm going to look and I'm going to do this, and I'm going to look at the conductors also here, because I'm doing the conductors and then I'm going to do the overcurrent device. And if you look at the overcurrent device, and just to get people in the right direction to start off, I pick up 630.12a. It tells you should have an overcurrent device rated or set, and listen to what it says one more time, at not more than 200%. So that, once again, you can't exceed it because it says not more. So here's another high percentage where we're doing what? Dropping down to the next standard size. So this in here, I'm going to size the conductor, which is a number 8 conductor. I go over, look at table 310.16, and I pick that up for 75 degrees C column. The next size above at 48.06 amps is 50 amps, which is number 8 conductor. Now I'm going to look at sizing the overcurrent protection device. So I'm still going to use the nameplate of 54 amps. And then I'm going to look at 630.12a, and you look at 12b, it all ties in the same there. It's going to tell you take it at 200%. So I take 54 amps at 200%, gives me 108 amps. And I can look at this 2 ways to what I can take and provide this protection. Now, I can say, all right, I'm going to protect the conductor 110 amps, but I'm going to see if I could just do 100 amps. Okay, which I can already tell you it is, because if I take 50 amps at 200%, what does it give me? 100 amps. See that? So I cross-check myself, and I could have just dropped down because I did go at the 200%, but I just went up to 110 amps just to sort of show you. A lot of people will say, I'm going to go up to 110, but really, would I be able to go down to 100 amp like it's saying not to exceed it? Well, sure, because I just put 50 amps on at 200%, gave me 100 amps. Right. So that is a good way of learning here. And you're learning the proper procedures to do these calculations. And then here, I've got 68 amp, and I've got 50% duty cycle. Okay, same calculation you're going to apply here that we just did. And you're going to do the conductors, and then you're going to do the overcurrent devices and see which one's the largest. I can already tell you. Listen.
Were you running around in my garage taking a picture of my welder or what?
I'm going to tell you what.
Just like my
that there are some very good illustrations that have been done.
That's a spitting image of my welder I got in the garage.
Yeah, the illustrations are fantastic. What's coming out, And I'll tell you, the grounding and bonding, man, it looks freaking fabulous. But the one I'm looking the most forward to, because they're going to redraw all new equipment and stuff, just like as close as we can draw it to where it looks like it, is going to be in the hazardous location area. Because you got all them bolts on it, and everything. They've already have drawn the purge and pressurized X, Y, and Z. They've got a couple of pieces already drawn of the explosion-proof equipment. They drew new seals. I mean, it's looking pretty freaking kick-ass.
Well, if I find them roaming around in my garage, man, I'm gonna want my cut, man.
All right. Now, this one is where the one we did before was non-motor. This is a motor generator type. All right. Now, we're just going to show you doing it without doing the conductor first. Because I can tell you can do the conductor, but before you said something, I was saying I can already tell you which is going to be the largest. It's going to be taking the 200%. But the reason we did that one before is to show you we took the conductor and got the amperage, took it at 200%, and it matched up to exactly when we dropped down. You see, and that proves everything that we're teaching you. Okay.
Right.
So this, and I've got a 68 amp load, and it has a 70% duty cycle. Now, look, if I was sizing the conductor, I definitely would do that 70% to size my conductor. But what we're trying to point out here is really all you need to do, you're sizing the overcurrent device, so I'm going to take it at 200%. Right? So if I take 68 amps at 200%, it says rated or set not more than 200%. That means I can't exceed it. Okay?
Right.
So the next size below that 136 amps is a 125 amp overcurrent device. Okay? And then when you come over here, you pick up a motor generator arc welder. So we got you an easy calculation. You know the welder. Looking at this, it's 76 amps. And we're just going to get the percentage. So I'm going to look at 630.12 A and B there. You're going to know to take it at 200%. Don't exceed the calculated value and drop down to the next standard size for your homework next week. Now, this one, we're going to prove this to you one more time. We're going to show you a resistance welder here. Now, in this one, you're going to look at 630.31A. Now, when I'm doing non-motor and generator type, I'm in 630.11A. Resistance, you're going to look at 630.31A. Now, this, and I've got an 84 amp primary, and I got a 50% duty cycle. Okay? So I automatically know my amperage, 630.31A. I'm going to use the nameplate, which is 84 amps. Now, I'm going to look at this table down here, and I'm going to pick up 50% duty cycle. It's going to come across. It's the first one in the table. It's going to tell you has a multiplier of 0.71. So I'll take the 64 amps at 0.71, gives me 59.64 amps. I look at table 310.16, 75 degree C column. The next size above that, 65 amps, which is a number 6 conductor. All right. Then I'm going to do my overcurrent device. Now, the only difference between these two, when I look at 630.32A and you're doing a resistance welder, you're going to take it at 300% instead of 200%. Okay? So I'm going to take the 84 amps at 300%, and that's going to give me 252 amps. Now, we're going to show you, looking at this overcurrent protection device, I'm going to do it one more time. I'm going to go up to the next standard size just to show you here. So here's 300 amps. Now, if I look at protecting the conductors, if I took that 65 amps at 300%, that gives me 195 amps. The next standard size above that is what? 200 amps. 200. So instead of putting a 300, I could drop down to the next standard size below that 252 amps. I could have went to a 250, or I could protect the conductors based on the 300%, which is what? A 200 amp. See the difference there? Most people would go to a 250, but you actually could go to a 200 here.
Yeah, so now the legend of the number 6 on a 200 exists.
Yeah, but look at that. That's interesting because a lot of people would just assume do the 300% and say, oh, I'm going to put it at 250 amps. or some may screw up and go to 300 amps. I'm saying I'm going to cross-check this to see if I'm right. So I'm taking that 65 amps at 300% for when I size the conductor. I come up with 195 amps. I just went up to the next standard size, which is a 200 amp, and that works perfectly fine. And I'll guarantee you, go look at some of these other publications out there. You won't see this. And you know, we do certain problems in here a certain way because we want you to think about what you're doing when you're taking these tests. And these are type of questions they'll trick you on. You may look at that and say, oh, it's 250. Well, if you'd have looked at the conductor took it 300%, you'd realize actually they're telling you the minimum that they could put on there is a 200 amp.
Right. And we really appreciate everyone smashing the like button. We got a bunch of likes in there tonight. Really appreciate it.
Oh, yeah. Thank you, guys. Appreciate that a lot. Now, look at here. That's a good-looking resistance welder they did there. I tell you, they put a lot of detail in these illustrations. And I'll tell you, when you throw it up on a big screen, they even look even better. I mean, because you see the detail that's in them. I mean, they blow them up and put the text in there just like you would see on a regular unit. So, I mean, they really do their work good. And then this one here, I've got 91 amp resistance welder with a 40% duty cycle. So, you know, you're going to look and get your amperage first, and then you're going to get your duty cycle and then work down based on the conductors in that 300%. Okay. And that way you'll know if you sized it correctly or not.
Right.
All right. And the next one we're going to look at is looking at control circuit conductors. Now, this particular one is where the conductors are located in the controller. And remember what I said when we were doing this. This is a verification for when you go look at 430.72B2. And I said when you're in there, it's going to have below the table, you're going to have your notes there and everything where all this ties in together. Okay. Right. And basically, when I look at this, since you're inside the enclosure, I said you're going to be looking at table 310.17 because that's considered to be in free air space. Okay. Right. So if I go over and now the other thing I'm going to point out, it's also going to tell you that you're going to use a 60° C column in this one. Okay. When I get to where it goes through the conduit over, then it's going to tell you use the 75° C column. So if I go look at table 310.17, pick up a number 12 conductor, it's going to tell you take it at 30 amps. And all I'm doing is checking here is the percentage that I'm going to be allowed here for the size overcurrent device that's required for the number 12s on those control circuit conductors. So it's going to tell you take it at 400% in table 430.72B. That's going to give you 120 amps. And I said anything over 125%, what do? Drop down. So the next size below that's 110 amps, and you'll see that all matches up with sizing the overcurrent protection devices. All right. And then here's showing you an illustration where I have the controller there and you got the control conductors inside that enclosure. Okay. And just remember you got this and we're doing a number 14 conductor. Just remember, because you're inside the controller, that's free air space. We're going to use table 310.17 and then I'm going to use a 60° C column and then take it at 400%. And you'll be able to size it and remember to drop down to the next standard size. Now, this is one where I'm running remote from the controller. Same exact conductors and everything, but looky here, now I'm using table 310.16. It's good for 20 amps, and it's going to tell you to take it at 300%, which equals up to a 60 amp overcurrent protection device.
Right.
Okay. And this is just a verification. The information's already in the table. All we're doing is showing you below the table and the percentages. How did they make that determination? This is how they did it. Okay. And then you'll see here we have the control circuit conductors run remotely over here. And then you need to use table 310.16, 75° C column, take it at 300%. And then size your overcurrent protection device accordingly. All right. Now, this is where you're going to get over and you're going to look at 430.72B exception 2. All right. Now, this particular one, when you look at this exception, this is where you're on the secondary side of a single phase transformer. And what it's going to tell you here is where you're going to be able to take this at 167%. So what they're going to tell you is in 430.72B exception 2, it's going to tell you to come in, basically, I need to determine my amperage. So this is very simple. You just get the VA of transformer, divide it by the voltage, there's your amperage. So we always get the amperage first. And then you're going to go back and you're going to look at table 450.3B. Okay?
Right.
Now, this is very simple because when you go over there and you look at that, I'm just doing the primary only here because we're talking about required for a primary 2-wire transformer here. And you go over and you look at currents less than 9 amperes. You come in and then you look at the next column. It says currents less than 2 amperes. So I'm between 2 and 9 amperes, right? So if I come down and I'm doing primary only, it tells me take it at 167%. But when you look at that table, you're going to notice there's no superscript 1 there like we talked about the other day. So if there's no superscript, what do? I drop down again.
Yep.
Okay. So you take the 5 amps at 167%, that's going to give me 8.35 amps. So the next size below that, standard size per table 240.6A, is a 6 amp overcurrent protection device. Okay.
Right.
And then you got the same thing here. You got a control conductors, or your control conductors, you got a control transformer there. Well, what do I have? I have a 2200 VA transformer. It's 480 volts. You're going to divide in that, get your amperage, then you're going to go look at table 450.3B to get the percentage. So in this case, if I was below 2 amps, then I'd take it at 300%. See that? And that's where you're going to look at table 450.3B. But I'll point out again, you're going to notice there's no superscript 1. Now, if I'm over 9 amps, then you take it at 125%, and guess what's there? A superscript 1, which means I go up to the next standard size. Okay?
Hey, I have a quick question for you. So is there any text at the top that's getting blocked off by like our live and by like our thing? Is there a way we could maybe shift that down a little bit so that, like, I'm just saying in future, like, I don't know if there's anything
what's
getting
being blocked.
So, like, I don't know for sure if there's additional text in there because it says overcurrent protection, but I know sometimes you have like text up there. I just didn't know if there's a way you could drop that text down. I was just questioning.
I can't drop that any. That's full screen right there.
Okay, gotcha. I was just curious because I just didn't want anybody to be getting any words blocked by that at the top.
Yeah, the only thing that's up top is just telling you what we're doing. It's just telling you what it is. Like it says overcurrent protection device, and we're doing remote control signaling and power limited circuits. And then at the very bottom is some sections that address that you might want to look at.
I just wanted to do like kind of a frequently asked question thing that people ask.
Okay.
No worries.
All right. Then we're going to do another one here. And this is where we're going to size the overcurrent protection device. And what size is required, where I have number 12 control circuit conductors that are tapped from the secondary side of a control transformer. And the primary is 480 volt and the secondary is 240 volt. Okay. So what I need to do, and you'll remember this, when we're tapping, I said always when you're tapping, you got to get what? The ratio of the transformer. So I would take the 480 volts divided in the 240 volts. We're telling you here that the number 12 has an ampacity of 25 amps. So take that ratio of the transformer times 25 amps. That's going to give you 12.5 amps. And then I'll drop down to the next standard size overcurrent device.
Right.
Okay. It's all very simple, but what is the main thing I did? I got my amperage first. That's all I'm trying to do. And in this case, there's no percentage or anything. All I'm trying to do is determine this based on the ratio of the transformer. Okay. And basically the ratio of the transformer, when you see that and you do the calculation, you're going to see it matches up to the conductors. That's basically what they're doing here. Okay. So we just try to prove everything basically, so you understand what you're looking at. This in here, you got number 10 conductors, okay, with a 408 volt primary and 200 volt secondary. So divide the 480 into the 240 volt and get the amperage number 10. That'll give you the amperage, and then drop down to your next standard size. All right. And then we're getting close to finishing this up. This is awesome. Now we're going to look a fire signaling circuit. This is actually given to you when you go over and look at 760.43, but we're just sort of proving a couple of things here. When you look at table 310.16, you pick up the 75 degree C columns, tell you number 16 is good for what? Number 10. Therefore, you look at 760.43, it matches up. You need a 10 amp overcurrent protection device. Pretty simple. And then we did a setup here. This is actually a pretty cool illustration because they actually come in and drew the new equipment and everything, and what you would see, the activated extinguishers, the alarm, the detectors and everything like you would see out in the field. And we're going to have you do here a number 18, number 16. You're going to do the exact same thing. You're going to go look at table 310.16 and size the amperage there, or get the amperage, not size it, and then size your overcurrent protection device for those signaling circuits. All right. And then this one here is where I'm going to get in to medium voltage here. Okay. And we look at this, we're going to do 3 1/0 aluminum conductors, and they're in an isolated conduit that's installed in air with a 3-phase supply voltage of 12,470 volts. Now, when you get into this, you got to look at your different conductors, because you're going to pick up table. Now, it used to be 310.60, but now they created a new article there, and you've got article 311, and you would be looking at tables 311.60, and if I'm not mistaken, I think it's like 52 to 72 or something like that. I can't remember them all. And then you go over there and you pick up your amperage for a 1/0 aluminum, and it's going to tell you it's good for 150 amps. And then when you go over and look at your long time trick element circuit breaker rating and 240.101, it's going to tell you to take it at 600%, which will give you a circuit breaker setting of 900 amps. Okay, next one we'll do is a fuse, and I think we're done with this, if I'm not mistaken.
What happens if they have to turn it up to 901?
Yeah. No, got it out, Paul. You don't know what you're talking about. Now, this one has 3 3/0 aluminum conductors. Once again, it's type NV90. You're just going to go over, look at the table. You'll look at, this case, table 311.60, C74, get your amperage, then come put your percentage on it, and then size your overcurrent device accordingly. All right. And then here's your fuse rating. It's the exact same question. The only difference is, and if I have a circuit breaker rating, it tells me to take it at 600%. But for a fuse rating, it tells me to take it at 300%. And it'll tell you here that you take the 150 amps at 300%, and you'll have a fuse rating of 450 amps. Okay. Nice. And you'll notice here, I got the exact same problem I had before. You're just going to take and do it at 300% instead of 600% to get that fuse rating size. All right. And that does complete us. Next week, we will complete the sizing your overcurrent protection devices. And then we start on residential calculations. Awesome. That's a lot of calculations in 8 weeks, brother.
Yeah.
So we're going to be real close to 12 weeks.
Dude, we got some special likes up in the chat there, so that's really awesome that you can bring that kind of heat, that things people haven't seen before. So appreciate everyone for participating too.
You know, one of the things that's been interesting since we've started doing this Journeyman Master Prep, we have had so many views. People, I'm getting messages all the time saying, "Thank you, brother. I appreciate, man. You really explain it well." And one guy, he goes, "Man," he goes, "I've been doing repetitions on it." He goes, "It's as easy as you say." He said, "Once you learn where to go get the percentages and just get that error," he goes, "It's freaking simple, man." I said, "Yeah, it really is if you know what you're looking for."
Well, and just to let you guys know, that was the whole reason I made the Nat King code page, was almost like what you were saying, kind of like a flashcard thing. So if you're getting ready to go take your test, you could just run through my page real quick, and you could just go find those questions, answer them, and all the answers are in there. And you can go through and just find them and just act like you're in the test and you don't know where the answers are, and go through and try to find them and give yourself like 5 minutes or whatever time limit you want. If you don't find them in 5 minutes, go look, okay, there's the answer, find it, and it's a good way to kind of, get yourself familiar just with that sight learning, and I really like it a lot. So appreciate everyone for participating to the Nat King Code page, and we will continue to the tool of the week.
All right.
It's time for tool review of the week. Sponsored by Electrician's Only Tool Review and Nipex Tradesman.
So the tool this week is one of my favorites. I try to mix it up with Milwaukee and DeWalt, and this is the DeWalt version of the Milwaukee utility knife folding. I really love these things. They've really grown on me. I've never really used them, but they have so many cool features. There's like so much stuff in them. The blade fits in there really securely, and then it's really easy to change the blade with a little thing over there. And then I like the one-handed operation. That was the one thing I was really spoiled me, because you're able to just hold that button and flip it out kind of like a switchblade. And it's really cool, especially if you're like unpacking a bunch of stuff. You can be holding something in one hand and be cutting it open with the other. It's really awesome. Make sure you have your gloves on, of course. But it's one of those products that I think has become popular recently, and I really enjoy it. And like I say, I'm not saying the DeWalt one or the Milwaukee one's better, but I really like this as a standard tool for every electrician to have in their hip pocket, and especially if you're a foreman out there, makes it easy to open up those packing slips, check stuff out, and get boxes tore open real fast, and keep a sharp blade all the time. I think this one possibly holds 5. Don't quote me on that, but they actually have a compartment that holds extra blades, so that makes it nice too, especially if you're cutting a lot of drywall, because you'll chew those blades up in days. So yeah. But yeah, that's my tool this week. I'm actually gonna buy one, and I'm gonna try the DeWalt version of it. I currently own the Milwaukee version. I did a review on it already, but I will get the DeWalt one and see if there's anything I can say that's maybe better than the Milwaukee version, or worse, or how, or if they're exactly the same. Who knows?
Okay. All right.
But code question of the week this week, for all you guys who are afraid of calculations, I don't think James is scared of calculations, so we'll see if he likes the calculations. So I threw you a little curveball this week, see if you can do calculation on the spot.
All right, let's see what you got here. You got 500 kc mil, and okay, you're using THW, and that. Let me tell people what you need to do here when you look at this. You're gonna he is throwing a curveball here. This is THWN, so you need to go look at table 310.41, and when you go over and you pick that up and you pick up THWN and you come across, it's going to tell you there in the third column for its maximum operating temperature, it says 75 degrees. Now, if he'd have put THWN-2, I could have used the 9 degree C column. But in this case, I have to use the 75 degree C column. Now, let me just sort of give you a little bit of insight here to what I'm talking about. If I go over and I look at 110.14C, okay? When you pick up 110.14C, I'm just going to read the last sentence in the first paragraph there. I'm not going to look at C1 and A and B there. I'm just going to read the temperature limitations. And what it says, conductors with temperature ratings higher than specified for termination shall be permitted to be used for opacity adjustment, correction, or both. Now that's interesting because it says temperature ratings higher than specified for terminations. Okay, so in order to be able to do that, I can have a 75 degree C termination here, but in order for me to use the 90 degree C, I would have to look at 310.4, look at my type of conductors. So if I had THHN here, I could use the 90 degree C. If I had THWN-2, I could use the 90 degree C. But he's tricking you here. He's using THWN, so that's your 75 degree C column. Now, when you do that, I'm going to go over and look at table 310.16. Let me get my calculator out here because I'm going to have to calculate this. I don't know this off the top of my head. So I come down, I pick up 75 degrees C, and I pick up 500 kc mil in table 310.16. It's going to tell you it's good at 380 amps. All right?
Yeah, you can see how I threw that in there as one of the answers. So people thought they were done right there.
Yeah, you ain't tricking me on that stuff. Now, when I look at the next one's the ambient temperature. Okay, so I'm going to look at table 310.15B11. Come down, I'm going to look at 125 degrees. You're going to be right in the 123 to 131. Now, what a lot of people do, they'll come across and do the 76%, but this is 75 degrees C column, so I'm going to take that at 67%. All right, so I've got that down. Now he's got 8 current carrying conductors, so I'm going to look at table 310.15C1.
That's
come down, you'll have 7 to 9 conductors. It's going to tell you to take it at 70%.
Oh, 70, right.
So I'll take 380. Just give me a second to add it up here. Times 67%. Times 70%. That's going to be 178.2 amps, so your answer is D.
Ding, 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 ding. I didn't get you this time, so that's awesome. And I didn't see Daniel's comment, but he's saying his safety guy hates those knives. I don't really see why, Daniel. Like, and me and Daniel, we go way back with the whole knife thing. One of the companies we worked for, I used to always say, leave your sharp knife and your feelings at the gate when you go into the job site.
All right.
They didn't want you to have a sharp knife, but.
Okay, your favorite time, Daniel. Willie Quiz. Here we go.
Get him.
You are now entering the zone of the Willie Quiz. Enter at your own risk.
All right. Well, thanks for everyone joining every week. If you guys are first joining, this is my Willie Quiz. Really doesn't have anything to do with electrical. I just try to throw together a little trivia quiz, and I try to attempt to fool James. Feel free to jump in the chat and try to see if you can throw in some answers. And
sometimes
try to
it's on electrical.
Yeah, sometimes. I do OSHA, I do everything. This week it's on kind of like bank robbers, stagecoach robberies, stuff like that. But the first one is the first gunfight ever between Wild Bill Hickok and Davis Telt was over blank. A, was it a horse and a gambling debt? Was it B, $25 and a pair of boots? Was it C, $40 and a beaver pelt? Was it D, $25 and a pocket watch? Or was it E, the famous poker hand known as Dead Man's Hand in Texas Hold'em? Good luck, everyone.
I know this one.
All right, Daniel comes right out of the gate with an E. That is a really good answer, Daniel, because the Dead Man's Hand is known as Ace 8, and
he's wrong.
The man who had that hand actually got a full house, aces over eights, and was shot dead after he left with his winnings. So.
What this one was, the only reason I know this because Dad has, he has like 3,000 Western movies, and
right.
I've watched them growing up and everything. And we actually went. I was trying to remember where it was. I can't remember where we were exactly, but I remember we went and they had a big thing on Wild Bill Hickok, and they actually did a Western show, and this is one of the things they talked about. I don't remember, if I'm not mistaken, I think you're trying to trick there and see, but I think I know it was over a gambling debt, and it was, I don't remember about being a horse, but I do know it was a gambling debt. And it was over $40 or 50 something, and Wild Bill Hickok only paid him half. And that's when the gunfight started. So I know it was a gambling debt, but it wasn't a certain amount that was paid. It was only because he only paid half of it. So I'm going to go with A.
All right. So, dude, James, I think you're starting to like cheat on these because you got that. You got that one partially correct.
Partially?
But the actual answer is D, $25 and a pocket watch. So what happened was it was a gambling debt over $40. He paid him the $40.
Oh, okay. That was close.
And then he wanted an additional $25. And Wild Bill Hickok says, I'm not giving you $25. So he snagged his pocket watch. And then he warned him. He says, if you're going to be walking through this square, you better not be showing that watch. And he came walking through showing that watch, and he freaking shot him dead. Oh. So that was the first ever gunfight in Wild West history. So I gotcha. Boom. Oh, awesome. And Daniel. I got Daniel, too. But Daniel had a good one because that was a famous gun story.
I did know about that. And but I don't know why I was thinking that, that was something I was a little kid when we went and did that, and I was just going off memory. I remembered something about it, 40 bucks.
No, you were right. You were right, because it was a gambling debt that they were arguing over. Mm-hmm. And what happened was he basically said, I'm going all in on this gambling debt, and Wild Bill Hickok won. And so then he goes, hey, you owe me $40. So he went and said, here you go, here's your $40. And then he walked away. He goes, no, you owe me $25 for something else, And he's like, well, I ain't giving you $25. I just paid you $40. And then he stole his watch and his pocket watch. And he says, well, he goes, that's fine. You can steal my pocket watch, but you better not be walking around with it. And then he walked around with it, and he just said, blam, shot him dead right when he did it. And then he took his watch back. So
that's something, because I remember something about $40, something that wasn't. I thought it was high. I took. Well, that was so long ago. But hey,
hey, your second answer was good. I could have given you a chance to get a second answer, but it's all good.
I always go for the first. All right, let's get to the next.
There you go. All right, the outlaw who is displayed as the outlaw who would never be captured alive was shot dead by police in 1911, and this was in a failed train heist. They actually heisted the wrong train and only got away with $46, but he was shot dead, and he was not buried until what year? Is it A, 1912, B, 1932, C, 1968, D, 1977, or E, 1985? Good luck, everyone. All right, so I could tell I got Daniel a little bit on this one. He hasn't answered yet, but he comes out with D, 1977. That's I don't know. I mean, you think he was not buried for that long?
I would think they'd bury him no longer than a year. I mean, that doesn't make any. I'm gonna go with A. The rest of it doesn't. I just don't believe they didn't bury him 20 years later. I just.
Yeah.
Where the hell was the corpse that they finally buried him? I mean,
so if you were to have a second answer that's not A, what would it be, James?
Shit, I have no idea. 1932.
All right, so James goes with B. And drum roll, the answer is D. Daniel is correct. So what they used to do back then is they would mummify him, and they would use him for traveling shows. And they didn't even know it was a corpse. It went around to all these different sideshow attractions and everything. And like his body was around, like I guess his body was actually around all the way till 1977. It was actually discovered in 1968. And then they were like, didn't know what to do with it. But it was meant to be, what they used to do back in those days is they would try to use it as like they would sell them to like carnivals and stuff, and they would mummify them, and then they would like use them to try to be like, don't be robbing trains or anything like that, you know, because then that's what this guy did. And so that was pretty interesting, and of course I got you again, but Daniel gets correct. Daniel gets correct answer D, 1977. So good answer, Daniel.
Okay.
All right. Question number 3. The first ever armed bank robbery, and this I should have put with a gun because there was other armed robberies before this probably that was with other things besides a gun, but this was the first ever armed bank robbery with a gun. Happened in blank by who? Is it A, 1866 with Jesse James, B, 1878 with Billy the Kid, C, 1863, Edward Green, or D, 1889, Butch Cassidy, and this was a successful robbery. They did get away. Good luck, everyone. All right, so Daniel comes out of the gate on this one. Oh, Daniel's trying to get you, James. He's trying. He goes with 1866 Jesse James.
That's
Good answer,
correct.
Daniel.
That's not correct. I think I know this one. I know it wasn't. I know two of them for sure. The first two. It's the last two I'm debating on. But I think, if I'm not mistaken, I think it was Edward Green, if I'm not mistaken. I think he was right before Jesse James. And let me think. It's A or C.
Okay.
I'm going to go with C. I think it was Edward Green, if I'm not mistaken.
You might have wished that you copied Daniel. But you are correct. The answer is C, 1863, Edward Green, the first ever. And Daniel gets second place because Jesse James was the second one to do it. Jesse James, they said, got away with over $20,000, and they never got solved. The whole thing never got solved. They don't even know for sure if it was Jesse James. It's rumored to be Jesse James, but the first ever was 1863, and it was Edward Green. He shot a 17-year-old in the face and took the money, and later came back and confessed because all of a sudden he was paying all his bills and everything. But well, it looks like Daniel. Yeah,
Rick, I missed two of them. What are you talking about?
You're gonna have to take it up with the trivia master, because I rigged nothing. But that was
I
awesome.
get 1 or 3 and it's rigged.
Like you both got 1 and 3, so
Yeah,
both of you tied for first. So basically, actually, Daniel, since you think it's rigged, I'm gonna give you the win. So James could gloat in his misery of losing to Daniel again. But no, it's a lot of fun, and I thought that was really interesting. I learned some stuff that I never knew before, and that's why I really like doing these. And it's really nice how the audience jump in and
It's
like
fun.
say,
You actually do learn stuff. I mean,
Yeah.
I think it's fun as hell. I like doing
Yeah.
it.
No, it's really cool. Well, I appreciate everyone joining the Willie Quiz, and horns up for you over there in Stallcup country. Thanks for being a good sport and letting Daniel take the win tonight. we're not rigged there, Daniel.
That's how you time it, you get the win.
Yeah. So it was pretty awesome. That was a lot of fun.
All right, let's see what we got on the wall of shame this week.
Shame. 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 Shame.
All right, so if anyone wants to check out where I get these pictures from, we have a group called the Electrical Wall of Shame, and it's really awesome that they let me steal these pictures. And this one is a classic. This goes way back, and this would never fly on any of the plants I worked on. But I knew you'd love this, James. When I saw it, I was like, "Oh, this one's a classic. This one's a keeper."
Wow.
I just could not believe that they would let that fly. I mean, I can almost guarantee that flange is not going to be capable of carrying whatever they want. And I almost bet that they failed this due to that, and they had to do something different. But, I mean, that's a lot of work to carve out that much metal and stuff. But
Hell yeah, that is. Wow.
Daniel knows. He's been on these kind of jobs before, and yeah, that never flies. Notching out a rated flange, dude. We've actually seen these flanges. They carry so much pressure. We've actually seen them where they don't have us anywhere near the facility when they're testing them, and we've actually seen them where they blew up so big that they put a crater in the ground. Like we came back the next day and they're like, "Oh yeah, it failed." And then we're like, "Oh yeah, where'd it fail at? I don't see anything." And then they're like, "Right over there." And you're like the pipe's gone, the rack's gone, big crater in the ground. You're like, "Whoa, that's what happened."
Oh yeah.
Yeah, that's a big no-no right there. Do not do that at home, folks.
It's just like explosion-proof equipment. You know,
Yeah.
you got to put all them bolts on and everything. How many times you gone in and seen where bolts were missing?
Yeah.
You know, you can't do that. I mean, because you got that flange that's there. I mean, it sets in there and holds it where, you know, because they got the ridges and stuff, and there's a reason that flange is designed that way, you know, and because I mean, those flanges blow shit. You better have it put together right. So
yeah, and you can see the amount of separation between where they put that notch and the actual pressure pipe.
Oh yeah, I can't believe they did that.
Yeah, I don't know. This had to be one of the #1 shame pictures of all time. So I knew you'd love it. I knew you'd deal with purge and pressurized and stuff like that, and you and Dad would get a kick out of that. So really
he
appreciate
actually gets a kick out of seeing all these things.
Nice. And that's cool. When I saw it, I knew it was right up your guys' alley. But it means a lot for everyone joining. Thanks, Daniel, for joining. We had Justin Gibbs pop in earlier. It's pretty awesome. Justin, I'll get back with you on some of the comments if you're watching this still. I'll get back with you and we'll talk some more about some of the stuff. We're always dealing with controversial stuff, and I really appreciate that, Justin. He's a big top member of the IEI and stuff, so it's really cool that Justin jumps in every week and joins us and stuff, and we get everyone jumping in here. Really appreciate it, and thanks for all the students that are trying to get their exam prep going and get that license. That's our #1 goal. Just make sure you subscribe to the channel. I was surprised we're almost at 260 now, so we're right on path for our goal. Like, we're a quarter of the way there, so just keep those subscriptions. Get your grandma, your uncle, your cousin, your aunt, everybody to subscribe to our channel, and we will hit 1,000 by summer. That's what we're trying to do, so
that'd be
really
awesome.
Appreciate it. Yeah, we're getting there. We're moving right along, so thanks a lot, Daniel. And Daniel gets a 4th win. We're going to give Daniel a 4th win against Stallcup all season, so that's pretty awesome. And, you know, we didn't have to go instant replay on any of my answers or anything, so James didn't have to throw the challenge flag or anything, so it's pretty cool. But appreciate it.
2 of those were ties.
Yeah. And we could call them ties and just give Daniel 3 wins or give him 2 wins and you 4 wins or whatever. We could count all the ones where you guys win against each other. But Daniel's a pretty formidable opponent, and I always get scared when you say you know it, and then I realize I have to try really hard to trick you and do different tactics to try to get some answers in there. But that one was pretty awesome because when I was checking it out, it was kind of crazy because, you know, like, it seemed like you'd think that Wild Bill was just this total animal, you know, but this guy comes up. I mean, the way he was acting, he should have just shot him right there, you know. But, you know, he says, "Oh, you owe me $40." He says, "All right, here you go, there's $40." Then he's like, "Well, now you owe me another $25." He's like, "Why do I owe you another $25? You said I only owed you $40, you know." And he was just being unreasonable. So that was really cool to learn about and everything. So,
well, I knew it was over $40. I sort of remembered that as a little kid, even, you know. And I thought he paid a half. I couldn't remember exactly what it was, and that's why I said I know it was a gambling bet, and it was over $40.
It wasn't really. It wasn't really a debt. What it was he had owed him $40, and then he goes, "Well, let's just settle it right now." And he goes, "I'll go all in on this gambling thing, you know." And so then they went all in, and then Wild Bill Hickok won. And then when he was walking away, he's like, "Hey, you owe me $40, you know, da 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 da." And he goes, "All right, here you go." He gave him his $40. And then he's like, "Yeah, but you still owe me $25. He's like, "What do I owe you $25 for? I already paid you what you said I owed you, you know." And then it was like a few days later, they were sitting there talking, And he just grabs his pocket watch out of his pocket. He's like, I'll take this for the $25. And he goes, all right, that's fine. You can take that for the $25, but I better not see it. It better not be out of your pocket. And so then he was walking through the square, and he had the pocket watch out, and he was looking at it and everything. He says, boom, and just shot him, killed him, So that was the first ever gunfight and stuff. So that was pretty cool, checking out history and stuff like that.
Yeah, I like it. I like doing history.
Yes, sir. All right. Yep. Right on. Thanks, everyone. I hope you got something out of tonight's episode. We have a lot of fun doing them. I have a lot of fun teaching James some trivia and teaching everyone else some trivia. And he's always a good sport to jump in and give his second best answer ever. And dude, tonight he even lost on the second answer. So you know what I mean? It's like. You're like 98%.
On one of them. Because the other one I would have done 40.
Yeah, you're 98% now, so it's all 98. Good.
Damn, I'm just dropping man, that's terrible. 98%.
Yeah, it's all good. But I appreciate everyone joining tonight. We had a lot of fun, and thanks for all the participation in Nat King Code. And remember, make every day an easy day.
Amen. Everybody have a good weekend. We'll see y'all next week. Don't forget to do your homework. All right. Let's roll.